Hi, this is chapter 27. It's about advanced machining process and the equipment about these processes. Up to now, we discussed several other machining processes like turning operations, milling, sewing, filing, broaching. There were many of them, but they're not sometimes sufficient to do some other, let's say, manufacturing operations on difficult materials, and that's why actually people develop some other machining processes, manufacturing process, and name them as advanced machining process. In some textbook or some other, let's say, sources, they may also be named as non-traditional machining process or non-traditional manufacturing process, but they're all referring to the same type of machining processes, which are quite new compared to the other ones. We can consider the previous ones as the conventional ones, but these are the ones actually described in this chapter are all called as advanced machining operations. And in the previous ones, what we were doing actually, we were removing material by means of chip formation, discontinuous, continuous chips, or microchipping, or in some of them we were removing material with the help of abrasion type of mechanisms. But here things might be a bit different, and the previous ones actually may not be actually enough in some specific cases. In which cases, for instance, if the strength or the hardness of the workpiece is quite high, for instance, as it's in here, the hardness above 400 HP, or the workpiece you are working on might be too brittle. Since if it's too brittle, then you cannot easily obtain complicated shapes with the help of the conventional processes. You should be careful. Or your workpiece might be too flexible so that you cannot easily do machining, or it may be thinner, longer. These are difficult workpieces, difficult shapes to be machined, to be worked on and with different operations. Or the parts may have actually complicated shapes. They may be, their sizes might be quite small, or the actually surface quality, the surface requirement might be too high, and we cannot satisfy these surface requirements with the help of the conventional processes. Or in other conventional processes, the temperature might be rising too much, and this will result in obviously some residual stresses. And if that is not actually acceptable for you, then you should go with some non-conventional or advanced machining operations. And it starts actually around 1950s. These processes are quite new processes. We'll discuss, and most of them can be applied on metallic or non-metallic workpieces. As I said, they are sometimes also called as non-traditional or unconventional. And we are not removing mostly gelatin chips. We will be using some chemical dissolutions. We will be doing etching, melting, evaporation, hydrodynamic action. These will be the main kind of mechanisms we are using in such actually non-traditional or advanced machining processes. I will start discussing the first type of advanced machining process. This is called as chemical machining, and as the name implies, we need to use some chemicals. So what chemicals are doing actually? They are attacking the materials and try to remove materials from the surfaces. And if you somehow control this process, you can do machining. And we will be using these fundamentals and try to obtain several chemical operations, and we will discuss some types of chemical machining. But in all of them, with the help of chemicals, actions, or reagents, what we are doing, we are removing little material from the surface. And it's one of actually the oldest type of advanced machining processes. Obviously, not the oldest manufacturing process, but the oldest advanced machining process. And we can use this process to actually remove open little shapes, complicated shapes of metals or hard stones, or even we may be doing some deburring with the help of this operation. And it's also utilized in the production of printed circuit boards in the electronics industry, or even maybe some devices can be manufactured with the help of this process. Now I will start talking about some types of chemical machining. The first one is chemical milling. So you know what milling is, and this time we will be doing the milling process with the help of chemicals, actions, reagents, and I will show you a schematic and try to describe this process on that schematic. But before that, I can say that this process is mostly suitable for obtaining such shallow cavities on larger products having sizes of 2-3 meters. It doesn't matter. But the thing is that once you do proper, let's say, masking before, then with the help of chemical milling, you see these parts can be removed and the thickness of the material can be reduced. So with the help of these, the weight of large products are reduced. And if you look at this case here, assume that the whole thickness is 4 millimeters. So after chemical milling, if it's reduced to 2 millimeters, then which means that we decrease the weight by half. And in the aerospace industry, it's highly utilized as they have larger products. You cannot easily remove these parts on, let's say, a milling machine. We need to have high machine, larger machines, and if you want to actually have such machines, then their costs are obviously higher. But with chemical milling, by applying some special maskers, special chemicals, you can do this actually material removal in less costs. As I said, I will be talking about the fundamentals of this process. Let's have a look at this schematic here. And this is a typical actually setup for chemical milling or chemical machining. So you see we have a tank, and this tank is actually filled with some reagents, or what we call them as actually etchants. They're the same. So this is filled with etchants. And then what we do, we simply put our workpiece into this tank, but obviously we don't put it on the floor of the tank, but we keep it inside this fluid, inside this tank with the help of a kind of an workpiece support. And furthermore, we have an agitator which actually stirs this etchants so that we will have a uniform distribution of the chemicals around this workpiece. And depending on the type of workpiece you are working on and the type of action you are using, the temperature of this tank might be important. With the help of these heating and cooling coils, we try to keep the temperature of the action at a constant value so that the chemical machining process will be as uniform as possible. So what we do in this process actually, you see there is a maskant. So before the process, we have this actually, let me try to draw it. So before the process, we only have this workpiece, okay, this blue workpiece. But later what we do, after cleaning, doing some extra operations, we apply some coating on this actually surface to be machined, and it's sometimes called as maskant. So what we do, we apply this extra material. So if that is the case, and this will be actually kind of which has resistance to these chemicals. So once you apply this maskant here, then that means our chemical, our reagents or etchants will not be removed material from the underneath of this region, which is actually masked with our special material. But if you have openings which do not have any maskant on it, then once you put it into this tank and start the chemical machining process, then we'll be removing material from this part, okay? This will be etched and we will have such openings as you see here. And another issue is that you may have such undercuts. Since once the machine starts, after some points, we will have such regions, such side surfaces where we don't have any masculine material. So they will be exposed to our chemicals, reagents, and they will attack again on these side surfaces and remove material from these regions. So that's why we will always have such undercuts. Let's have a look at the one on the right hand side. And with help of this actually operation, we have kind of a step profile. You'll see we have 3 steps in this chemical machining process. We first apply this maskant and then remove on this much, okay? Which means that, for instance, we may be applying this much of, let's say, maskant and then putting it into our tank for 1 hour, okay? And then only this amount of material will be removed. Let me again annotate that part. So with the first actually step, probably we are removing this much of material, okay? And then what we do, we remove this part and actually do our masking up to this point. And then this will be the second amount of material we removed. This is the second part. And lastly, once you remove all these maskings and apply another one, that will be actually, this part will be removed from our top surface. So in each time, actually, we are removing almost same amount of material. So let me use another color for the second region. Yes. In each step, actually, we are somehow removing the same amount of material from the surface. But again, we have these overcut issue, undercut issue. Material under this actually masking is also removed due to the side effects, side attacks of our chemicals. And people are actually aware of this problem and they try to design their, let's say, maskings and the profiles accordingly so that the resulting workpiece will be acceptable according to their needs. And here the steps of this chemical milling is actually steps are summarized. The first thing we need to do, we need to remove the residual stress on the top surface of our workpiece. Since if we do not relieve them, then probably after the chemical machining, we will have some warpage. So this is the first thing we need to do. How we can do it, we may do sandblasting, shot peening, so that the stress on the surface, residual stresses will be relieved and its shape will not be affected after the chemical milling operation. And then in the second step, what we do, we clean the top surface so that while we are applying the masking material, it will be actually adhere to the surface easily. And another advantage of this cleaning is actually you will have a uniform material removal. Since if you have, let's say, thinner masking at one point and thicker masking at the other point, then we cannot obtain a uniform material removal rate. And what we do, we apply the maskants as it is done here, and then peel off the unnecessary regions. For instance, if this is initially what we do, this is actually, let me use blue. So this is the amount of actually material, masking material we are applying. And then what we do, we remove these interior portions, and only masking will be remaining at these regions. Okay, this is the fourth step actually, peeling off step, and then simply we put our workpiece into this tank, and then actually chemical machining starts. And in this operation, sometimes we need to control the temperature, also the uniformity of the agents, the chemicals. For that purpose, we need an agitator and also some heating and cooling equipment. And then in the sixth step, what we do after this machining is processed, we take our workpiece and clean it with water simply so that there will be no extra chemical operations, chemical machining, and the depth of cut will be the same while we are actually removing this workpiece from the tank. And lastly, we simply remove this masking material, since these will be remaining even after the machining operation is completed. So after everything is done, we need to apply maybe special solvents so that these mask materials are removed. And furthermore, if you're not satisfied with the quality, you may go on with some extra finishing operations as we discussed in the previous chapter. And if it's a kind of an step, let's say, profile, then you need to perform these processes as you like. As I mentioned, this machining process, chemical machining process, mostly utilized in aerospace industry. They have larger products and they want to reduce the weight of these products since it's quite difficult to move these heavy products in air. That's why they need to have parts having low weights. And furthermore, you can use the same approaches to actually fabricate some microelectronic devices, some chips, since silicon wafer can easily be actually etched with the help of this machining process. And you can see the quality of actually chemical machining. If you look at the surface roughness values, it's somehow similar to the surface roughness values we obtain in the turning operation. And its tolerance is again somehow similar to turning, so the quality is not worse, quality is fine enough, and this has, as I mentioned, very advantages, especially in terms of manufacturing very large products. And the disadvantage is that if you cannot actually carefully control this process, then there might be some damage on the surface. You may have some cracks, or there may happen intergranular attacks, or the metallurgical properties may be worsened, and you should be controlling all the parameters so that the resulting parts would have the same properties before you start the chemical milling or chemical machining operation. Then we have chemical blanking. It's a very simple process. What is blanking? First of all, blanking is actually, let me draw, assume that this is your initial material, and after a blanking operation, if you are removing this part, and if this is going to be used, but this part is scrapped, then this is called as blanking, since after this drilling or other kind of punching or different operations, this part will be used, but not the other part. So this is called as blanking, and we can do the same by using chemicals. If that is the case, then the process is simply called as chemical blanking. And now I will talk about the last type of chemical machining. This is photochemical blanking, somehow similar to the previous one. I spent some time on chemical milling. It's very similar to chemical milling, but the thing is that this time we are using some photography techniques. So what are these? If the part is quite small, you'll see there are some example parts which are obtained with the help of photochemical blanking. And they have very little features, their sizes are quite low, and if you want to produce many of these at the same time, so photochemical blanking is actually a useful process for this purpose. So what we do in this process, again, we have some steps. And what are these? First of all, we design our part having a size of actually 100 times larger size. So let's say if your final product is 1 millimeter actually in size, 1 millimeter square, then what do? You design that part having 100 times larger size. So we will have an, let's say, 100 times 100 millimeter square of, let's say, area. We will be designing our part in that large area. Let me try to illustrate these processes. Okay, assume that this is actually the workpiece we are going to produce, okay? Let me have it, make it a bit complicated, or let's keep it as it is. So this is actually, this ellipse shape is actually our part, and we want to print it, we want to manufacture it by using photochemical machining or photochemical blanking. So what we do first, we design this part with a magnification up to, let's say, 100 times, since we may have some little features inside, but I don't want to draw something inside to keep things simpler. And so what I'm going to do, I will then obtain the negative of it, okay? Since this was the required part, this is the part we want to have after the machining process. And then what I do, I take the reverse of it or the negative of it. So initially, this region is actually desired part, but after we take the negative of it, you'll have such a shape. Try to draw the same one, and this time that part will be actually let's say change color. Okay, so this is the negative of it, and this ellipse is actually the part we want to have. Okay, so with the help of this magnification, we can simply remove or eliminate, decrease the design errors, since if the part is larger, then we can easily add such features and then decrease its size by 100 times. And then what we do, assume that, let me draw our workpiece, and I will this time draw a side view, okay? This is a side view of our blank material. It's a sheet metal probably. This is our workpiece material, and we want to machine this ellipse shapes out of this red part, okay? And then what we do, we apply some, let's we use other color. We want to actually do some coating on top of this blank material, okay? Now the whole surface is covered with actually photosensitive material, which means that once you apply let's say light, and then some part of this material will be cured or polymerized properly, it will be solid, and the other parts can easily be dissolved. So what we do, and then later in the third step, we put this blue part actually, let me try to draw this blue part on top of it. I'm sorry, I need to make it blue. So this is my, let's say, negative actually design, and I'm assuming that this 100 times magnified actual design is reflected into a small region, into the actual size of my part, okay? And I know that there is an opening here. Let me try to draw such a kind of a lines here, so that once you apply lights, let's use, okay, sorry, draw lines, okay. And then what we do, we apply lights onto this setup. So this is actually, yes, the third step, okay. So the third step, we obtain the negative. This blue one is a negative, but we decrease the size of it once again, and then we put this negative on the top of our coated blank. Our blank is the red one, coating is the orange one, so this is coated blank, and we put this negative onto top of our actually coated blank, and then apply UV light, okay? With the help of it, let me use another color this time, use black. Since these regions were actually, let's say, covered, light can only pass through this opening, okay? So this part will be actually cured, and it will not actually let our chemicals go into our workpiece. So after this step is done, and then in some, let's say, time, what we will have such a shape. Let me try to draw once again. I will use again the mask and color. So this is the shape which we will have after some time, which means that we now applied coating only on this region. And then what we do, we simply take this part and put it into the same tank, same type of tank. We have chemicals inside, reagents or agents inside, and later we wait for, let's say, some time. And then what will happen, obviously, I will draw the last case. In the last stage, we'll only have, I'm sorry, I should be using, obviously, black. I should be using red. So that is the part remaining. And we still have some agent on it. So after this chemical machining operation, we now have only this part, okay? And later what we do is simply remove this black masking material and have only this black red part, which is actually the ellipse shape we designed earlier. And as I said, in order to keep the thing simpler, I continue with this ellipse shape, but it may be anything. It may be a very, let's say, complicated shape like this here. So that's why it's a very nice process. We can produce very complicated and very small products with the help of photochemical machining, photochemical blanking. And as you see, these processes are quite, let's say, cost-friendly. But the thing is that you need to have high skills to do these processes, and it can easily be automated. So depending on your, let's say, type of products and the number of products you're going to manufacture, you may go on with this process and increase your overall productivity.